Have you ever stopped to think about what it really takes to clean up the world's biggest messes? And I'm not talking about, a messy kitchen. We're talking about the invisible, powerful science that keeps our most important industries up and running.
All right, let's get into it.
I mean, really think about that. How in the world do you clean layers of thick, caked-on grease and gunk from something as massive as an oil rig or a giant refinery tank? Yeah, you're not exactly going to reach for a sponge and some dish soap. The scale of this problem is just on another level. So what's the secret? Well, the answer is chemistry, specifically powerful alkaline chemistry. This is the secret weapon that professionals use to literally dissolve the toughest organic grime you can imagine. And we're going to break down exactly how it pulls it off. See, this is way beyond just soap and water. This is about waging a full-on chemical war against grime. To deal with things like heavy oils, stubborn organic deposits, and baked-on carbon, you need a solution that can attack it right at the molecular level. And this, right here, is where the magic really happens. The whole idea is to create a high pH environment. This super alkaline state is basically the worst nightmare for grease and oil. It launches this multi-pronged chemical attack that just breaks it all down so it can be washed right away. And this attack isn't just one move, it's like a 4-hit combo. First up, you have saponification, which actually turns the grease into soap. Then comes emulsification, which traps all those tiny oil particles in the water. After that, dispersion breaks up any solid gunk and scatters it. And finally, hydrolysis uses that alkaline environment to just chemically shatter the molecules. All four working together, it's a system designed to absolutely obliterate grime. Let's zoom in on the real star of the show here, saponification. This is literally the exact same chemical reaction our ancestors discovered thousands of years ago to make soap from animal fat and wood ash. The alkaline solution takes a greasy, oily, water-hating mess and transforms it into a basic, water-soluble soap that you can just rinse away. It's an ancient chemical trick scaled up for modern industry. Pretty cool, right? But of course, you can't just use any old alkaline chemical. Professionals have this whole toolkit of different compounds to choose from, and each one has its own special strengths for different jobs. Let's look at the two big ones. So your two heavy hitters are caustic soda and soda ash. Think of caustic soda or sodium hydroxide as the sledgehammer. It's super strong, it's super effective, and it's pretty low cost. Perfect for those really heavy-duty degreasing jobs. Then you've got soda ash. It's much milder, so it's the tool you reach for when you're working with more sensitive materials that can't handle the raw power of caustic. But the toolkit doesn't stop there. Pros will also use things like trisodium phosphate. And really importantly, they use these specialized commercial detergents. These aren't just one chemical. They're these perfectly balanced recipes that often include things called surfactants and other additives. Those are like little helpers that boost performance. They help the cleaner get deep into the grime and, crucially, keep it from sticking back onto the surface. Okay, so we've got the science and we've got the tools, but where does this all come together in the real world? Well, you see it in action in really critical places, like the oil and gas industry. This chemistry is absolutely essential to their day-to-day operations and maintenance. And the number of jobs it does is just huge. We're talking everything from just general degreasing of equipment to pulling out stubborn hydrocarbon gunk from inside pipes and vessels. It's used to clean out massive storage tanks and to get a surface perfectly prepped before it's inspected or painted. Heck, it's even used as the first step before they bring in the acids for an even deeper clean. And this isn't just stuff in a textbook. There are specialist companies out there, like Bowsher Energy, that have built their entire business around mastering this chemistry. Their technicians are out in the field every single day, applying these principles and using their expertise to get the job done right and safely.
And that brings us to a really crucial point. Using these incredibly powerful chemicals isn't just about brute force. It's a very delicate balancing act, one that requires a ton of expertise.
Just look at this trade-off right here. Sure, you can crank up the temperature and the chemical concentration to get a faster, more powerful clean, but that also cranks up the cost and, more importantly, the safety risks. On the flip side, you can go with a lower temp and concentration. That's safer and cheaper, but you might not get the cleaning power you need. Finding that perfect sweet spot for every single job, that's the real skill. And that brings us to the number one rule of this entire business: safety. Let's be really clear here. That corrosiveness is no joke. These chemicals demand respect. Without the proper handling, the right personal protective equipment, and super strict safety protocols, this powerful tool becomes incredibly dangerous. There is zero room for error.
So when you boil it all down, what does it all mean? It means that successful industrial cleaning is a perfect partnership between two things: the raw power of the science itself and the skilled, experienced human expertise needed to apply it. You can't have one without the other. One is just ineffective, and the other is just plain dangerous. So we've seen how this unseen chemistry keeps our world running. But that leaves us with one final, very important question to think about. It's a question of responsibility. This chemistry cleans up our industries, but what does it take to clean up the chemistry itself? How do you properly treat the wastewater and safely dispose of these powerful solutions when the job is done? That's something to chew on.